All right, what's up, my mathletes? That's right, Mr. Muscarella coming at you, and in this video, we're going to take a look at domain, range, and end behavior for linear functions. So, what's a linear function? Just makes a straight line. Glad you asked. So, now you know something a little bit more about the word linear. Now, let's go ahead and take a look at all this stuff, but before we do, make sure you have a pencil ready. And this was one of the biggest pencils in the world that I got to see this past summer in August of 2021 in Casey, Illinois. And that is not the biggest pencil in the world, but it's pretty close. It's 32.5 feet long. And the end of it that has lead is actually all covered up, and the other end of it that has the rubber eraser, that's out there. But this thing is huge, man. It's pretty cool. So if you're ever going through Casey, Illinois, be sure to stop there and enjoy all the big things that are there, because it's not just that. There's the biggest rocking chair, biggest golf clubs. There's a whole bunch of stuff there, so be sure to check those things out. Now, when we get into domain and range, I mean, this should be a little bit of review, right? You should know domains where the x values, where that function is defined, and the range are the y values where the function is defined. Now, the technical writing skills, right, coming at you. Domain, we'll use a capital D to write domain. Now, for range is kind of like the paragraph symbol in English class, because you know how in English you have like the P with the extra line in it, and that means paragraph. Well, range is kind of similar to that, except for it's with an R. So you got a little bit extra line there with that. So those are the symbols we'll use for domain and range. Now, left and right hand end behavior, we're going to kick that up a notch, and it's going to be a little bit different than it was last year or in previous courses, because now you've graduated from those. You've moved on. Your life is bigger, better, and brighter. So here we go. First thing you want to do is kind of think about the x, y axis. All right, now, if you go all the way to the right, that would be all the way out to where infinity would be. If you go all the way to the left, that's where the negative numbers would go all the way on and on and on forever to negative infinity. And on the y-axis, if we go up forever and ever, we just keep going up, then that would get to positive infinity, because you go up to 100, 1,000, a million, a bajillion, and we would never stop. So we just keep going up forever, so we just call that infinity. And likewise, if instead of going up, we went down on the y-axis, then that would approach negative infinity, because those numbers end without bound, or they don't end. You know, there's no bound to them. So when we write left and right side behavior, that left end behavior. So what we're doing is we're looking at the ends of the graph. So we don't care about the wiggles in the middle. We don't care about where the arrows are pointing. And so we'll notate that the left side, we're going to look at a left arrow, and we're going to denote it like this. We're going to use limit notation. And we're going to say lim, and this LIM means limit, as x approaches. Now the left side, so keep this in mind, right? The left side is over here. So we're going to look and see, does the arrow point up or down there? And our function is usually going to be given, you know, a general name like f of x. Now, if we're looking at the left side, we're going to need a little negative infinity. So the way that you read the lim part is you say the limit as x approaches negative, and I'll just abbreviate that, neg, and then you can use a little infinity symbol, or you can just write negative infinity like that. It's up to you. But just know that that's how you pronounce that. That's how you translate all the symbols. And then, of course, depending on which way the arrow points, it'll only point up or down. So our answer could be infinity or negative infinity. So I'll just put kind of a blank there. But you could either have infinity or negative infinity. So depending on which way the arrow points, it's going to be one of those two answers. All right, so that's a little bit about that for the most cases. All right, now for the right end behavior, almost the same setup, but on the right side, we're going to look over here at that part, because we're going to look all the way to the right, and we're going to look and see, does the function go up or down? Or maybe it stays the same or doesn't do anything. More on that later. So notation-wise, we'll write that lim part again, LIM, as x approaches infinity. And that is the piece that means towards the right. So whenever we talk about the right end behavior, we're looking over on the right side of the graph, towards the positive infinity on the x-axis. We're looking over there at our function f of x. So you need all of those pieces, the lim, the x, the little arrow, the infinity, as well as the f of x. And you have to be careful here, because sometimes, you know, it might be called a g of x or an h of x. It might have a different name than just f of x, but generally speaking, it's f of x. And then again, that could be infinity, negative infinity, maybe it's just a value. And every once in a while, we may get DNEs. We might get something new here that you may or may not have seen before. And if you ever come across one, we'll do an example one. DNE, that's going to mean does not exist. All right, so that might be something new for you. So we'll abbreviate that shorthand-wise just by saying DNE. Now we're going to take a look at the linear functions. They're all going to fall into one of these four categories, right? Positive slope, negative slope, zero, or undefined slope. So let's go ahead and take a look at the positive slope line. And we're going to go ahead and do the domain, the range, and the end behavior. Now when you sketch these, you're going to want to just kind of generally speak or draw an XY coordinate grid. And then we're going to add some negative infinity down here on the y-axis and a positive infinity up there on the y-axis. And then over on the right side, we'll have a positive infinity on the x-axis, and on the left side, we'll have negative infinity. So all of them are going to start out with that kind of general picture. Now, a positive slope line is just going to be some line that's going to go probably through the x and the y-axis, maybe only one of them, who knows, or both of them. I don't know, maybe that's a thing. They have to cross both. Who knows? But more on that later. We can talk about that in class for show. But you're going to have a line that kind of goes uphill in a nutshell. So when we look at that, when we look at those pieces, we're going to take a look and start to analyze it. Now the domain, and this is true for all of the linear functions with a positive slope, the domain is always going to be, so if I look to the left side and the right side of the line, it's always going to go on forever and ever and ever in both directions. So that means the left and the right, I can pick any x value. Now, at the same time, my range, it's going to go down forever on the left, but it's going to go up forever on the right. So again, I'm going to have a negative infinity to infinity for my range as well as the domain. So for a positive slope line, it might shift, it might be somewhere else on the graph, but it always is going to look like that. Now when we talk about the left-hand behavior, so we're going to abbreviate that LEB for left-hand behavior. So again, we'll start out and we're going to write that lim as x goes to negative infinity part of f of x. So we'll start out writing that. And then the left-hand side, let me see what color I used there, so green. All right, so this part right here, oops, that's definitely not green. Come back here, there you go. So this side, so I want to look at that side of the graph, the left side. And then I have to analyze the arrow. Does the arrow go up and down? So I've got to look right here. And that arrow goes down, so the part that is down is right here on the y-axis. That's going to denote negative infinity. So my answer for this would just be negative infinity. Now conversely, if I look at the right side, so my right-hand behavior, you're going to have the limit as x goes to the right side of our function, f of x. So again, I'm going to look over on the other side. So on the right side, ooh, look, that goes up forever and ever and ever. So that is going to denote positive infinity because that's going to go up on the y-axis forever and ever. Boom, chakalaka. Now, negative slope, you probably already might start to get a little inkling on this one. Negative slope is going to be the exact opposite, right? So think about that because you have a line going across the x and y axis. But this time we're going downhill. It's like we took the choo-choo train, we took the roller coaster to the top, and now we've got to come down. So la-di-da-di-da-di-da-da. Ooh, I wanted to do that in red, so let's go back. So there we go. So we have a negative slope line. Now again, our axes, I want you to draw an infinity out here and up there on the y-axis, and then a negative infinity and a negative infinity on those two parts of the x and y-axis. And again, I'm going to talk about the domain and range and limit from the left side and the right side. So our domain and our range, both of these are going to be the same as they are for positive slopes. They're going to be forever and ever in both directions. So we don't have any limits that would stick out. There's no holes or removable discontinuities. There's no jumps in the graph. That'd be called a jump discontinuity. We don't have any irregularities. They just go on forever. Now when we look at the left-hand behavior, so now we're going to look at the left side. And on the left, so I'm looking over here, and I got to look and see what direction does my function go. Well, it goes up. And on the y-axis, the part that's up is infinity. So when we write that, we would say on this one, the limit as x approaches negative infinity of our function f of x is going to be, since it goes up, positive infinity. Now conversely, if we look over on the right-hand side, so when we look at that right and behavior, our limit this time as our function goes to infinity of f of x, that is going to be, so looking on the right side, I look at this arrow, the arrow goes down, so that's going to denote negative infinity. Boom. So those are the two left end and right end. Those are the end behaviors of our function. Anytime you got a negative slope line, it's always going to look like that. All right, so those are the first two. We've got a positive slope and a negative slope. Now, zero slope and undefined slope are going to be a little bit different. And you'll see because of the way those pictures look. So let's just go ahead and sketch that out. We've got a nice little zero slope line. So I'm just going to draw my infinities around here because you always want to put those on there. So negative infinities. Oops. And sometimes you get going so fast, you get an extra line in there. And that's one of the things. Just try and make sure that your work is nice and neat and organized as always. Now we go ahead and look at this. A zero slope line, and it could be anywhere. And I'm just going to put it right here, up here on the y-axis. So it's going to cross the y-axis. It's going to be a horizontal line at some value, and I'm just going to call it A for awesome. So at some value, A, we're going to have a zero slope. It's a horizontal line with this. Now, again, if I look at the left side and the right side, like this line goes on forever and ever and ever to the left, as well as forever and ever to the right. So when I talk about the domain and range on this one, both of these are going to be negative infinity to infinity. Now, the left and right end behavior, that's where things are going to get a little bit different. So if I look at the left end behavior, now on the left side, I've got negative infinity. Well, notice it just goes forever to the left, but it's at the same value, this y equals a, because it's always going to be some number. Say that was at y equals 4, then it would just be 4 everywhere. The y value would always be 4. And if I look on the right side, so if I look over here on the right side, it still goes at that same value. So in this case, the zero slope one, both the left hand and the right hand end behavior, they're going to be the same because they just stay at whatever the number is. So a shorthand way to write this, you could separate it or you can write it together, and you would do that by saying this: the limit as x approaches negative infinity of f of x would be equal to the limit as x goes to positive infinity of f of x, and that would equal whatever this magical number a is. All right, so if that was up on the y-axis at y equals 4, then that value would just be whatever we've got going on there. So those left and right end behaviors, they're both going to be the same anytime you have a horizontal line. All right, so just be, tuck that away. I mean, that's going to be one of those important little points there. Let me shrink that down a little bit. Here we go. See, I love when you can do that here. But that's going to be true anytime you got a zero slope. Anytime you have a zero slope. Now, if you wanted to separate that, you could also do each one individually, but it would still be A for both of them. And if they're both the same, you can just go ahead and put A right there. Now, for the undefined slope, when you have that, so again, we're going to go ahead, draw our little graph here, infinities, negative infinities right down here, and then a vertical line anywhere you want. We're going to call this, say, x equals some number b, for booyah. All right, so we've got some vertical line. All right, undefined slopes, remember they're vertical lines. So when you look at this one, again, this is our domain and range. And actually, we need to go back here for this one because I made a boo-boo because I was thinking ahead too much. So the domain and range, let's talk about that with the undefined slope. Then we'll go back and fix the zero slope one. When you got the undefined slope, your domain is only going to be whatever that one value is, which in this case is just b. Right? Because all my x values, whether I'm here on the line or here on the line or there on the line, they're always going to be the same x value, and it's just going to be whatever that value is for our vertical line, in this case b. So similarly, when we take a look at the zero slope one, so let's go back over here for a second. If we look at that, which part would always be the same value? Would it be the domain part or the range part? Which number would always be the same? Hopefully, you came up with the word range. So the range in this case would always be whatever that value a is. All right, so apologies on that. That's going to be the case right there. So for the domain of zero slope, it's all rails, but the range is only a. Only a. Now with an undefined slope, they kind of switch positions, right? The domain goes on for only one value, But the range, however, the range is going to go, it's going to go up forever and it's going to go down forever. So the range is going to be negative infinity to positive infinity. So my apologies on that, but that's all you got to do for that. Is the domain is going to be some number b, and the range will be all real numbers for the undefined slope. Now this is a tricky one too, because if you look at the left side of the graph, there is no left side of the graph. There's no right side of the graph. We just got this wall right here in the middle, this b. So what we got to do when you say that, so the left end behavior and the right end behavior, they're also going to be the same on this one, the left and the right end behaviors. And for this case, all right, because there is no left side and there is no right side of the graph, so when you write that, we'll still start out the limit as x approaches negative infinity, as well as the limit as x approaches positive infinity of our function. Both of these, since there is no left side or right side, this is the one, so cool, where we say DNE does not exist. Because there is no left side and there's no right side. There's just this wall in the middle at some value b. So any undefined slope is going to have that general setup, just as well as any zero slope or any negative slope or any positive slope. So that's it. You just got to be able to recognize which one of those four shapes that linear function would make. Based on the shape, boom, you got all the stuff right there. All right, so we're going to practice 4 examples right now, just these 4 right here. So refer back to those pictures, and then let's check it out and see how you did. And then we'll go through it together, so see if you're good with it. But check with a couple people around you if you're in my class. If you're not in my class, go ask a neighbor anyway and see what they say about it. So I want you to sketch it and then do the same thing, domain, range, and end behavior, using correct mathematical notation. All right, so go ahead and hit pause, and then come on back after you've talked with somebody, and let's check it out and see how you did. All right, you rock star, how'd you do? That's right, example 1, you should recognize this guy right here, right? So that's my clue right there, because that is a positive slope. And so when it's a positive slope, we have a line that's generally going to be shaped like that. And looking at this, you should be able to take a look and say, oh, my y-intercept, because there's my -3. So -3 is my y-intercept. So you know this coordinate, 0, -3. That'd be a point on the graph. All right, so without further ado, the domain and range are, boom, negative infinity, positive infinity, all real numbers. And then left and right end behaviors. The left side, the y values go down forever. But on the right side, they go up forever. Boom. All right, so make sure that your notation is good and pay attention to all those little details so that you're solid like a rock. And then on example 2 here, check this out. So this one, again, when we look at it, we're going to analyze this part right here first. All right, that's my negative slope. So since that slope is negative, that's what I'm gonna have generally that slant of a line. And again, we can look at the y-intercept of +4 and come up with a y-intercept for it. All right, and generally that's the shape of our line right there. And then we look for the domain and range, all lines that are slanted, so either having a positive slope or a negative slope, they're all going to be negative infinity and positive infinity for the domain and range. Now left and right end behaviors, they switch up. They're the opposite of a positive slope. So the limit as x goes to negative infinity of f of x is going to be up forever to infinity, and the right end behavior is going to be down to negative infinity. So make sure that your notation is good and you'll be all solid on that. Then the last 2 there, examples 3 and 4, right? They're just the same way as they were in the examples, except for this one. On these, you're going to have the y value is going to be 3. So for the line y equals 3, your limit from the left as well as the right is just going to be 3. Domain is all reals on that one for example 3, but the range is just that. There's only one y value anywhere on that line. No matter if we go here or here or here or here or anywhere in between, that number, that value for the y will always be 3, which is why your range is just 3. Now, notice too, when we write these in our notation, we've got a little hard bracket around the 3 compared to the domain where we have soft brackets around negative infinity and infinity. Because the 3 is included, we use a hard bracket, and infinities and negative infinities, they're always going to get a soft bracket, which is how we mathematicians describe it. We don't say parentheses because that's English. We just say soft bracket. All right, so a little bit of mathematical vocabulary there, hard and soft bracket, which I know at this point in your mathematical journeys, you've heard those terms before. Now, lastly here, let's check out example number 4. Make sure we rock that one out. Again, domain's only one value because no matter where we go on this line, it'll be 6 for the x value. No matter what, we're always going to be at 6. So our domain is only 6, bro. That's it. Can't be any other number. The range, it goes up and down forever, that vertical line. So that would be infinity to infinity. Then our left and right hand behaviors, it doesn't exist. Now, if you want to combine that junk, right, you can put it separately like that, or you can put them together and just say the limit as x goes to negative infinity of f of x would be equal to the limit as x goes to positive infinity. And you always write the left side first. All right, so you don't want to get those backwards, of f of x equals dne. So you can write like that as well. All right, so that's it for this video. I know this one was a little bit longer. I usually break them up, but I'm going to give it to you straight in one on this one. Now, from last night's homework, you know, go ahead and take a look at, or 2 nights ago, worksheet 1-3, and take a look at that. Just pick 5 and describe their domain, range, and the end behavior. All right, so that's it for this one. Thank you guys for watching, man. I love you, I miss you, and I hope you have an amazing day, and I'll catch up with you guys soon. Peace out.